Hello, today I want to walk you through how to create simple but advanced state machines for your own Godot projects. We will cover how to define states within a state machine and define acceptable transitions between those states. There's a lot to cover, so subscribe to help other aspiring game developers, and now let's begin. I'm going to start off this tutorial by explaining state machines, and then we'll move into the tutorial at this timestamp if you just want to skip there. So what is a state machine? Well, basically a state machine manages the flow of logic, but it does it in a clean and more organized way than if we were just to use a ton of if, and else statements. When using a state machine, it has different set states, and it switches between those states while having one state active and all the other states as inactive. So instead of the messy if-else statements and hundreds of variables that look something like this, we can create the exact same effect by just doing this. And this is the code that we will be creating today. As you can see, it's going to make your game a lot more modular, and it's going to allow you to make more advanced states and more advanced animations for your players or enemies. So hopefully that little explanation can give you a little bit of insight into state machines, and now we can get going into the tutorial and you can actually understand what is going on as we're creating this state machine and what you can use it for in your own projects. Okay, so now that we understand what a state machine is, let's get into creating one, and we're going to end up doing this with the use of an add-on called LimboAi, and we can actually download this add-on straight from the asset library here in our engine by going up here to the asset library and just typing in LimboAi. And it's going to kind of organize everything for us in state machines. We still got to create everything. We still got to kind of do the work, but it's going to make everything a lot easier, and it actually makes your game run much smoother. And I really do like this. And with LimboAi, there's a lot more features to it, like behavioral trees, which you can make in, intelligent AI, which I'm going to actually go over in the next video, where we're going to end up making an intelligent enemy, and it's going to know how to walk around, when to attack, when to do everything, right? And it's going to be really cool and super advanced as well, and it's going to be makes everything a lot simpler. And we can end up using this for state machines, and that's what we're going to be doing today. We're just going to be creating a basic player state machine, but with the use of LimboAi. So LimboAi, that's how we get the entire add-on, right? Is asset library, click here, and then click download, and then you'll have it in your game. You don't have to move anything, drag and drop. You don't have to enable anything. Even up here in the project settings, where we have plugins, you don't have to click enable like you do for most add-ons, because I don't know why that is, but for LimboAi you don't have to, and it's already automatically enabled. As you can see up here at the top, we have a new tab, LimboAi. We're actually not going to be making use of this today because this is more of the behavioral tree type of stuff. So if you want to create AI, that's where you do that, and I'm going to be going over the next video, of course. But in this video, let's learn state machines. So right now, let me go over what we have in our game. So we have a world scene, which has a static body with 2 tile maps, and we have a player scene, which only has movement, and it has no animations, no jump, no anything, right? So this is our script. We basically have an onReady var to our animation player and our animation sprite. I'll show you why we have both here in just a second. And then we have a speed, gravity, and a direction variable, which we set our direction based on our input, and then we kind of check, well, if there is a direction, that means we have some sort of input, so let's end up moving that direction. And if there's not, then that means we want to kind of slow down, and then we have gravity, and then we have our move and slide. And we also have project settings, input map, which is just going to be some inputs, down, up, left, right, and attack. So if you want to go and create those. And the reason I have the animation player and the animation sprite is because in our player, we end up having this cool attack, right? It's an attack animation here in our animation player, and I couldn't make it within our animated sprite. So I kind of made a animation here in our animation player, and if we click play, you're going to see it's kind of like a little attack. And our animation sprite also has an attack, so we're kind of going to overlay them. If we play this one, all it is it looks like that. But with the other one on top, it looks a lot better. And this is 4 frames a second. This one shows for 4 or 3 of the frames. This one shows for 1, so it's shorter and longer. And that's kind of it. But if we overlap those on top of each other, the animation does look good. So I have to kind of play both of those when we want to play the attack animation, but that's all going to end up happening later, right? So let's get started with creating our actual state machine, right? And to do that with LimboAi is super easy. So we need to first of all create our state machine variable, and first of all we'll end up setting this in a function whenever we initiate our state machine, which we'll do in our ready function. But if we do var state machine, so this is going to be our main SM, which is going to be state machine in this case, and we can set this to a limbo HSM. Now Limbo, of course, is the add-on. HSM is the hierarchical state machine. So that's kind of what this means. It's a class, and we're going to set our main state machine to equal one of these later on whenever we create a new state machine in our function. Now, to do that, let's first of all create a function in our ready function, which is going to basically be our initiate state machine. And initiate means to create, to make, right? So we're going to initiate or create our state machine. We're going to end up doing this in another function just to make everything a lot cleaner. And if we come down here, we create this function. I completely forgot to put function in front of that. Don't know why, but we can do something like this and we can just pass for now. So I'm going to zoom in on this a little bit so we can see it a bit better. But in this state machine function, we are going to want to end up calling a way, or we're going to end up wanting to change this variable into an actual state machine. Right now it's just set to equal this class, which it's not equal to anything yet. It has no value. But if we do main state machine equals a limbo state machine dot new, basically meaning we're creating almost like a new resource for this variable. So it's going to be equal to this. Now every change we make is going to be equal into this file. This is kind of a file now, and every change we make to the main state machine is going to be saved within this file. So we need to also add in our state machine, because right now we have created a state machine, but we haven't actually added our state machine. So we can't make any changes to it until we add our state machine. So we can just say add child state machine. And then we're going to end up needing two more variables in here just to make our state machine work. First of all, we're going to have to say, okay, well, main state machine dot initialize. Basically, again, what initialize means is we're creating it. And then we're also going to have to say, okay, well, main state machine needs to be set to active, just in case we have any other state machines in our game or in this specific script. So if there's any more state machines in this script, then this is going to be set over priority on all of them. So this is the active state machine. And then now we're going to end up creating our states, right? To have a state machine, you have to have different states. So we're going to end up having an idle state, an attack state. We're going to have a jump state, and we're going to have a walk state for our player. And those are all going to be changed based on what is happening with our input and with our game, right? So to create a state, to define a state, we're not actually going to be adding the state to the state machine yet, but I'll explain that in just a minute. But to define each state, they're all going to be defined in a variable, and we're going to create them in separate variables. So we can say, okay, well, var idle state. So this is going to be our idle state. We need to go to, okay, well, limbo state.new, basically creating a brand new state that's going to be stored within our state machine, right? So we're going to create a new limbo state, and then we can name this by whatever we want this state to be called. So if we want this state to be called the idle state, then we can call it the idle state. Now this is where it gets a bit confusing, and you're going to have to kind of pay attention here. And that's because we're about to use some LimboAi functions that aren't in Godot, right? So we're about to create two of them. One's going to be called a call on enter, and one's going to be call on update. Basically, what these are going to do is the call on enter is going to call whenever that state first starts for the very first frame. And then after that, whenever that state is active, we're going to end up calling the call on update function every single frame of the second, like a physics process. Now let me write it out so it kind of, you can see visuals, but we're going to have call on enter. So basically call on enter, and then we're going to put the function name in that we want to call whenever we first enter this state, which is going to be idle start. And then we're going to have another one, which is going to be call on update. And then this is going to be the function that we are going to call every single frame that this state is active. And these functions we're going to actually have to come down here, and we're going to have to create them, right? So we can say function idle start and pass, and then function idle update. And this is actually going to be sort of like a physics process, so we have to have delta. You can set that as a float, and then pass. Now let me walk you through this one more time. So we have our idle state. We're creating a new LimboAi state, right? So okay, we know, okay, this variable is going to be a limbo state, right? Okay, then let's name it idle. So now we know that this state is named idle. And then whenever we first enter this state, we want to call this function, but we only want to call it one time. And every other frame of the game that this function or this state is active, we're going to end up calling this function. So this is going to make more sense whenever we put print statements down here in just a little bit, because we're going to end up saying, okay, well, print idle start and then print idle update, so we can kind of see how it's calling the functions. But that currently can't happen until we finish setting up the state machine, right? Because the state machine right now is not set up. So right now we're going to need to define every single state that our player is going to have, right? We have idle, we're going to have the walking, we're going to have the jumping, and we're going to have the attacking. Now, let's start making the other ones. So, okay, we'll var walk state. It's going to be our next state. This is going to be a LimboAi state. It's going to be a new one, right? Because we don't have it yet. We're going to name it our walk state and then call on enter. So whenever we first enter this state, what function do we want to call? Well, we can call our walk state, or we can call our walk start, and then call on update. What function are we going to want to call every frame that this state is active, right? So every frame that this state is active, we're going to end up calling this function here. And we can come down here and we have to, again, create these two functions. So we can actually, to make this a bit quicker, copy these two functions, paste it, and then rename the idle within them to a walk, right? Just like that. And then we have to create the other two states as well. Now I'm going to do this in a time lapse just to make it a bit quicker since it is repetitive for all the states. Okay, so basically what I did was create our walk state, jump state, and attack state. They're all done in the exact same way. We just rename them to their whatever their state is. Of course, we create them all as a new state, and then we have a call on enter function for all of them and a call on update function for all of them. So basically, if we're in our walk state, whenever we first enter our walk state, we're going to call this function, right? But then if we end up switching into our attack state, we'll end up calling this function and then calling this for the rest of the duration of that state being active, if that makes sense. But we have the states defined, right? We know what they are, we have them here, but we haven't actually added them to our state machine. So to add them to the state machine, what we can do is we can say, okay, well, main state machine dot add child, and then we can just basically add in our idle state, and then we have to do this for every single state that we have. Then we can say, okay, well, main state add child, and then we are going to end up adding in our walk state. We are going to end up adding in our jump state to our state machine. And we are also going to end up adding in our attack state, right? Okay, so now all of our states, we define them here, then we end up adding them to our state machine. So now they're in our state machine, and our state machine knows what our states are, right? And let me go over one more thing real quick, which is going to basically just set our initial state. So whenever we first run the game, we're going to have a initial state. So if we say, okay, well, main state, state machine, main state machine, and then initial state is going to basically be equal, we want it to be equal to our idle state, right? When we very first start the game. Now, look at this. What we can do is if we click play, we're actually going to be inside of our idle state. So if we go into our world and we click play, we're going to be within our idle state. Now, it's not going to show anything, of course, but we can do that print statement thing that I was talking about just a minute ago, right? But we end up getting an error here, and that's because we spelled initialize here wrong. We forgot an A in there. Click save. We go to our world. You're going to see that we are playing. We are technically in the idle state now. We can't see that, but we are in the idle state. So if we go to our idle start down here, we can say, okay, well, let's print idle start, right? We are now in our idle state. And then down here, we can say, okay, print idle update. So basically, if we're printing idle start, that means we're running this function. If we're printing idle update, that means we're running this function. If we print, let's print the walk, right? That's not going to do anything, of course, because we are right here set in our initial state. Let's just do this to make sure it's not printing, right? But you can see, okay, well, main state, initial state, basically it's going to start it as a default state. So now we should run this when we first run the game and then run this for every other frame because we have no way to switch the function or switch the states yet. But if we do click play, you see idle update is running. If we scroll all the way to the top of that, you're going to see that the very first one is idle start, which means we called this once, and then we're calling this for the rest of the time that is active. So let's think about this for a minute and say, okay, well, what are we going to want to do if we, what are we going to want to actually put in our idle start to actually see something visual within our game? Well, let's just play our idle animation, right? So we can say, okay, well, animation sprite dot play. our idle, right? Now what's going to happen is if we click play, you're going to see that off the start, we're going to end up playing our idle animation, but nothing else is going to happen because we never switched the state, so we don't know what to do in the other states. So to do that, we have to go over something else within our state machine, right? So we're going to have to end up setting up our state transitions. And to do that, we're going to have to define a couple of different transitions, and we're going to have to go over how we want to transition from this state to this state and the method that we're going to use, or the method that we're going to call to transition from state to state, right? So to do that, we can come down here, back in our state machine script, and we can just say something along the lines of main state machine dot add transition. So we're going to basically add a transition to our main state machine. Then we're going to, you can kind of see right here, it says, okay, so this add transition function is a LimboAi function, and it's going to say, okay, so the from state, so what state are we coming from? And then what state do we want to transition into? And then what is the event, which is like basically kind of what is the signal that we're going to call, and it's going to know that signal and then transition from that to that. So let's just start off basic and say, well, idle state to our walk state. So to do idle to walk, we can basically say if we end up calling to walk. So if we call to walk, basically kind of like is saying, like if we say, okay, well, now we're in the walking stage, let's move into the walking stage. We can actually set this up right now. So we're going to set it up because it's going to make a lot more sense if we actually set it up and you can see how it works. But you can say, okay, so we're going to move from the idle stage to the walk stage if we call this event. So this is our idle stage. Remember, this is going to be called every single second that the idle is going on. What are we going to want to check for to move to our walk stage? Well, we can actually check and see if our velocity is equal to 0 or not. Because if our velocity is equal to 0, then that means we are in the idle state. If it's not equal to 0, that means we are moving. So if we're calling this while we're in the idle state, and we end up detecting that the velocity is no longer equal to 0, that means we are moving and we need to switch states, right? So we can say, okay, well, if velocity.x is not equal to 0, then we want to end up saying, okay, well, let's get our main state machine and let's dispatch the event, or dispatch the event or the signal to walk, right? So we can say, okay, well, to walk, that means we're going to end up switching into the walk stage or the walk state. And down here in our walk state, we're going to end up printing walk, which it's going to work. It's going to say, okay, well, we printed walk, but we need to remove this and we need to say, okay, well, let's actually play our animation. So let's say animated sprite dot play, and let's do our walking animation. And down here, we can actually check to make sure if velocity is equal to 0 or not, because if it is equal to 0, that means we want to go back to the idle state. So we can say, okay, well, if velocity dot x is equal to 0, then we want to just say main dot dispatch, and we haven't created it yet, but we will. And we can go to say state ended, right? And I'm going to explain why we're going to end up doing state ended and why we're not going to do a different event for that. But let's go over that now before we actually test this out. So if we go to main state machine and we say add transition, let's create a new transition. Let's actually do this from any state, because basically, let's think about this for a second. If we're in the jump state, at some point we're going to transition into the idle state. If we're in the move state, we're going to at some point transition into the idle state. If we're in our attack state, we're going to at some point transition into our idle state. So Limbo has this cool thing. If we say main state machine dot any state, so basically it's any state that we've created and added to this state machine, we can do that, and then we can transition into idle state. And since this is any state, that we can end up naming the method something more, I don't know, something more universal, as in the state has ended, right? The state ended. Basically, the walk state ended, the attack state has ended, the jump state has ended. We want to go back to our idle state at all those points in time, right? So if we click play, you're going to actually see that we're in our idle state. If we walk, we're in our run state. Then we're back in our idle state, right? So we're walking, idle, walking, idle, walking, idle, walking, idle. And you're seeing that it's not flipping. The character's not flipping. So to fix that, we can actually come up here real quick and just write out a very quick function and say something along the lines of flip sprite, just like this. And then we can pass through our direction through this variable. And we can just say function if direction is equal to 1, then we want our animation sprite dot flip h to be equal to false, because that means we're facing to the right. Else if direction is equal to -1, then we want our animation sprite dot flip h to equal to true, right? Because that means we're going to be facing to the left and we want to actually flip our sprite. So that should work. Now if we click play, you're going to see that we're in our idle state, we're in our run state, idle state, we flip this way in our run state, idle state, just like that. We can't jump or anything, so let's go over that. And I also wanted one more thing. Let's print our current state. So we can actually do print our main state machine dot get active state. If we call this function up here, you're going to see if we click play that it's going to print, okay, well, look, we're in our idle state. Now we're in our walking state. Now we're back in our idle state. Now we're in our walking state, back in our idle state, right? So it's going to end up tracking that. So we'll just leave that there so we can know. And then now we're going to end up transitioning into our jump state and our attack state. How are we going to want to do that? Well, we're going to end up having to make some more transitions. So main state machine, add transition. Basically, let's think about this. So if we're in our idle state, we're going to want to be able to jump, or we're going to want to be able to transition to our jump state. If we're in our walk state, we want to be able to transition into our jump state. If we're in our attack state, we don't want to be able to transition into our jump state, right? So we're going to end up having to create two transitions to move into our jump state, but we can use the same method to call them, right? It's like kind of like it's like an if or else if statement, right? So we can say, okay, well, our idle state, and to move state, or well, I don't know what I'm doing. Idle state to jump state, right? So idle state to jump state, and we can do this by calling on our to jump method, right? So we can, if we say to jump, then it's going to end up transitioning. But we also can use this exact same transition, but instead of the idle state, we can move from the move state into the jump state. But we don't want to be able to move to the attack state into the jump state, and that's why we're not using the any state. But to move from any state to the attack state, we do want to do, right? So if we're in the jump state, we want to be able to move to the attack state, because then we can fall down and it's like we're kind of attacking from the air. If we're in the move state, we want to be able to attack, and if we're in the idle state, we want to be able to attack, right? So to do that, we can basically use this one up here, and we can say, well, the main state machine transition, and we can go from any state to our attack state, and we can call this the to attack method. And that should all be set up. And this is, we actually said move state. I guess we called it the walk state, like this. But these are all of the transitions. So basically, if we're in our idle state, we can move to the walk state. If we're in any state, we can move to the idle state. If we're in our idle state, we can move to the jump state, and so on, right? So that's kind of how that's going to work. If we're in our walks, or basically if we're in our walk or idle state, this is kind of like an or statement, but it takes up 2 lines of code. And then this is going to be any state can move into our attack state. So how are we going to end up moving into our jump and attack? Well, we're going to end up doing different things in the code to basically get our input by the input map that we created, or that we went over earlier. We're going to use this up variable, or this up key, which is the W key to jump, and we're going to use the attack, which is the space to attack. So to do this, we're going to end up calling another function, which is basically going to be a function to handle our input. So to do this, we can end up saying function unhandled input event, and then we can check, okay, if the event dot is action released the up button, then we want to basically say, okay, well, main state machine dot dispatch, and we want to dispatch our jump because we want to now move into our jump variable. So we can say to jump, and then we can say else if event dot is action released is the attack button, then we can say, okay, well, main state machine dot dispatch, and we can say to the attack. So we can kind of say to attack, just like this. So if we click our attack button, then we're going to move to the attack state. If we click our up button, we're going to move to the jump state. So how are we going to go about this, and how are we going to go about creating our jump? Well, creating the jump is actually going to be pretty easy. We're going to come down here to our jump ready function, And in our jump ready function, we're going to have to do two things. We're going to have to end up calling our animation sprite. So we're going to say animation sprite.play jump, our jump animation. And then we're also going to call our jump here by using a jump power function, which we haven't created. But we can just create this real quick and say jump power. And we can equal this to maybe negative 400. Then down here we can say velocity dot y is going to be equal to our jump power. And kind of what this does is this is just a basic jump. We're just going to basically change our velocity in our jump start. Since this function is only going to be called once, we can't do it here in the jump update because then we'll end up going up forever. So we have to do it here. So it's called one time. So we set our jump power. So we're going to end up going up into the air. And then what are we going to want to do in our jump update, right? Let's think about that. So in our jump update, we're going to end up wanting to basically check if our player has hit the floor. Because whenever we hit the floor, that means we have landed back on the ground and the jump state's finished. We need to change back to our idle state. So we can kind of just go, well, if is on floor, then we can say main state machine dot dispatch, and we can call that state finished that we created. So the state, or the state ended, I think we called it, just like this. And if we click play, you're going to kind of see how this works. If we end up clicking our jump button, we're going to transition into the jump state. We're going to end up playing our jump animation just like that, and it looks good and it works. If we look down here, you can kind of see we're in the idle state, we're in the walk state, now we're in the jump state, and we kind of switch through the states just like that, right? So that works really good. Now we need to go and create our attack state. So we already transitioned into our attack state by clicking the attack button, but we don't actually do anything within the attack state. So to do something within the attack state, we're going to end up having to go and say, okay, well, what do we want to happen whenever we enter our attack state? So first of all, in our attack start, we're going to just set our animation dot sprite dot play to our attack animation. And remember how I said that we have those two animations? So we end up having to call our animation sprite and our animation player to play both animations, and they're going to end up overlapping each other at the exact same time. And something that I want to do within our attack state, because I always want to attack to the right of the player, and to do that we can just basically hard code our direction to equal to 1. And since this calls every single frame, it's always going to be equal to 1 whenever we are moving, right? Whenever we're in our game, it's always going to be equal to 1 because it's called every frame, so it's updating the direction every single frame, if that makes sense. And then in here we can basically kind of see, well, if our animation player is going, or let me show you how this works. So if we print our animation player, which is an animation player, basically just an animation player where you can create your own animations, then we can say current attack, or I mean current animation, and we can print this out. Let's go up here and let's actually code this out so we don't see that, because it's going to fill up the code. But if we go to our world, we click play, you're going to see that we have no animations because we're not using the animation player, but we're using our animated sprite to play these animations, not the animation player. But if we click our attack, you're going to see it's going to play the animation, kinda. It's not going to work because we never switch the state out of attack, so it's always stuck in attack. But look at the animation player. Look how it kind of tracks it. So if we click it, you're going to see it's going to play the attack, and then it's going to end up playing a bunch of nothings because the variable goes back to null. And what we're checking here is we're checking the animation player and we're checking the current animation. You can see how it's empty here right now. But so if we check to see if the current animation on our animation player is equal to null, or if it's equal to attack, that means we can kind of see if the animation is still going. The moment the animation ends, we want to switch out of that state because the animation's over. We're done with the attack. So how are we going to do that? Well, we can come down here and we can kind of say, we can use this code here. We can just say if animation player is equal to the attack, then is not equal to the attack, then what do we want to do? Well, we want to say main state machine dot dispatch, and we can say our animation has finished. So then we're going to end up transitioning back into our idle state, right? Okay, so we have something messed up. We forgot to take this away here. And if we save that, everything should technically work. And one more time, I want to go over, so our animation player right here, because I feel like I was a bit confusing there, but our animation player just has one animation. It has the attack animation. Because we are playing this animation, the weapon is a separate animation than our animation sprite animation. That's why we have to call two, because they're basically overlapping. Every other animation is done here in our animated sprite. No other animation is done in our animation player except for the weapon's movement, basically, right? So if we click play now, you're going to see that everything should work. We're in our idle. We're in our walk. We can jump, where we go to our jump state, just like that. We can walk. We can attack. It works. Attack. It looks a bit, funny just because of the way that everything is set up. But everything does work. And it looks really, really good. So the reason it looks a bit funny is because it's not like polished. It's just like, but the states work. And the animations aren't really that good, to be honest. Like this animation here, this attack animation I created, it looks kind of funny. I'm going to be honest with you. It looks a little bit funny, but it works. I just wanted to get the point across and try and help you understand the how you use these state machines and how you're able to create them, because state machines are something that everyone needs to know. They are so powerful, especially when you start to get in more complex code. A good state machine is going to make or break your game, truly. For example, if we go up here and we take this away, if we start printing again, you can kind of see we're in our walk, idle, we're in our attack, jump, and we kind of keep track of all of our movements, right? So that looks good. That looks really good. And I really like the way that this came out. I really like the way that this add-on helps with the state machines, because without this add-on, state machines are pretty complex. Now remember, the cool part of this add-on is going to be the behavior trees. I'm going to go over that in the next video, and we're going to kind of create this enemy that has complete intelligent AI and has all the AI behavior and functions on its own, and it is really, really cool. So that you can use that for NPCs, enemies, and all that type of stuff. And I'm really excited for that as I've been playing with it, and it really does look amazing. It turns out amazing, and I'm super excited for that. But I do hope that this video was able to help you in some way cover state machines for your own game if you need state machines. And the state machines are super important. They are super helpful. They keep your code concise, and they don't overcomplicate things, and they make everything a lot simpler, so your scripts aren't full of if-elses and all those type of different things that are really going to clutter up a script and make everything much more confusing. So I really do hope this video was able to kind of explain state machines and hopefully help you create your first state machine or help you learn a new way to create state machines. And until next time, stay safe and have a wonderful, wonderful rest of your day. If you have any questions, let me know in the comments. I'll be sure to get back to you. I want to help you guys all out. Thank you so much, and I hope you did learn something. Until next time, stay safe and have a wonderful rest of your day. Bye-bye.